Bye, Billy.
Enchanté.
Yorkshire.
Garçon.
Hi, I'm Jack, the design engineer and team principal of Unity Racing. This is me, but to understand how I got here, we have to go back. No, further than that. Even further. No, not that far. That's better. This is me, at 10 years old, getting my first taste of engineering in motorsport. It's a long way from the technical brilliance of Formula 1. But hey, we're off to start somewhere. And for me, that just so happened to be a lawnmower engine strapped to the back of a wheelchair. Suffice to say, I've come a long way since then, with my passion for engineering only growing stronger. I started in my best mate's garage over 8 years ago, and together we now run our very own AV company, Stjärnor, alongside a 320 square foot workshop that supports all of our personal engineering projects, along with enabling a lot of my STEM racing success. Over the years, I've been involved in a multitude of engineering projects, each one teaching me a valuable lesson, with some being more successful than others. My first major project was designing and installing a 5 kilowatt solar panel array to make our original garage workspace more sustainable. We integrated it with a 30 kilowatt hour battery pack, allowing us to store energy for powering our machines and supporting future projects. This was a huge success in cutting our power bill down to near zero, and was a huge step for reducing our emissions as a company. Currently, we're building a working replica of the Fanuc Robodrill, a CNC milling machine with a robot that's capable of loading it and unloading it remotely, meaning that in theory we should be able to run it 24/7. This project hasn't been easy, and there's been lots of setbacks along the way. Here's a time lapse from one of our most recent build sessions. No matter how hard we try, you just can't build a replica of a full-scale CNC machine without any money. So how do we actually fund these engineering projects? At its core, Stjärnor is an AV business, meaning that we put on events around Scarborough and the local area, doing all kinds of things, from weddings to parties to whatever the hell this is. Yeah, that's enough of that. I think we've seen enough. But in all honesty, we do put on some really good events at Stjärnor. We work with local bands like the Cloughton Rat Pack, we do local panto productions, and most commonly, parties and weddings. One of my other competitive projects was Green Power, where me and my team built a single-seater, fully electric race car. Unfortunately, we made quite a drastic miscalculation by putting our least experienced driver in the seat first. This led him to forgetting which lever was the brake and which one was the accelerator. It goes without saying, this set us back a few days, with multiple parts requiring immediate attention, especially because the competition was only a few weeks away. But we pulled together as a team and got the car ready to race, ultimately leading to us winning the Best Engineered Car Award for our innovative regenerative braking system. To answer the question, what excites me the most about a career in engineering? It's the limitless potential to turn ideas into reality. Whether that's through installing a 5 kilowatt solar array to reduce your power bill, or pushing the limits of what's possible with simulation to produce the fastest F1 in schools car, or even developing a rolling road wind tunnel to push the limits of aerodynamics further. Every project is an opportunity to solve problems in creative and meaningful ways. I'm motivated by the challenge of working with constraints, whether that's budget, materials or time, and finding clever solutions that not only work, but excel. I think I'd be a perfect fit for the Academy, because I combine real-world engineering experience with the persistence to turn challenges into achievements. Over the last 8 years, I've led projects in renewable energy, robotics and motorsport, often working with incredibly tight budgets, mimicking that of Formula 1 due to the cost cap. One example of a huge collaborative project was running the 2024 North Yorkshire Children's University graduation event, one of the largest and most complex events I've been involved in. Over 4 days, I coordinated a team of 6 Stjärnor employees to install a 10 kW PA system, a 24 square foot stage, a 6 metre truss arch, and a disco set up downstairs, all in one of Scarborough's biggest churches. This project certainly wasn't without its challenges, including a DJ who didn't even show up on the first day, and us needing to strip apart part of the upstairs sound system mid-event to keep the downstairs party running. We overcame these challenges by staying calm and communicating effectively, with some of us running the DJ equipment and others fixing problems as they arose. The result was a flawless 3-day event with over 1,000 students from across North Yorkshire. Doing events with Stjärnor is the ultimate collaboration, because I have to work with individuals with a wide range of skill sets, whether that's rigging or programming or even DJing. All of us are working to one end goal, and, as I'm sure you're aware, no matter what happens, the show must go on. These experiences reinforce exactly what Komatsu and Williams value: perseverance, collaboration and the ability to deliver high quality results under pressure. It may not be the same field of engineering, but it's the same approach I'd bring to the Academy. Technical know-how combined with the resilience and teamwork needed to push boundaries. So far, it's been a lot of me talking. Let's mix it up a little bit. Here's a quick tour of the Stjärnor workshop. This is the heart of our operation, Stjärnor's server room. Built over the last 5 years from broken, repaired and second-hand parts from eBay, this monster powers all of our IT needs. In here, our server has over 400 CPU cores, 4 terabytes of RAM, and over 150 terabytes of total storage. The cable supplying this server rack can deliver up to 180 kilowatts of 3-phase. The raw power of this server room enables us to run ANSYS studies faster than both the design teams at Unity Racing and Stjärnor can pump out CAD designs combined. Another secret weapon of our server room is that it's all networked by our 10 gigabit network switch, enabling anyone on our team to access their files and simulation data from anywhere in the world, whether that be Saudi Arabia, Singapore, or even just at college. And this is my workspace. Once again, all powered by the server. This is where I do all of my CAD and simulation work. I use our Bamboo Labs P1S printer for rapid prototypes, which I then take to the wind tunnels in the next room over. This is another project I'm working on at the minute. It's a control system for a rolling road wind tunnel. It can go anywhere from 0 all the way up to 3000 RPM. It has a resolution of 0.1 RPM, and this way we should be able to map our acceleration curves directly from our simulations back into the wind tunnel, more accurately validating our testing. This is the testing zone. Once one of my prototypes comes off the Bamboo Lab printer, it makes its way down here, where we can test in a physical wind tunnel with our 1000 watt Magnum Hazer and compare it back to an ANSYS simulation study. For one of my personal engineering projects, I've been working on a replica of the Fanuc Robo Drill. This project is designed to aid my understanding of CAM and CNC technologies. When finished, this machine will be able to rinse out F1 in School's prototypes in just under 2 minutes. We can run as many different design iterations as we want, because the robot can automatically load and unload the machine. Consequently, this also means that we can run the machine remotely from anywhere in the world. Through the skills that I've learned in STEM racing, such as CAD and FEA, I've carried out the mechanical design on this project, making sure that it can work safely and as expected for years to come. This project has taught me a lot about mechanical design and how to be resourceful, especially considering we're limited to whatever materials we can 3D print and some scrap steel box section. As you can imagine, 3D printing a bracket that can take the load of a full robot or CNC machine is no easy task. But through proper testing methodology and rapid prototyping, we're now closer than ever to having a fully working system, hopefully machining our first parts in the next 6 to 12 months. Ultimately, I live and breathe STEM racing, but the equipment and industry connections I've built along the way allows me to do so much more, preparing me for the real-world engineering challenges, such as those that I'd face at the Komatsu Williams Engineering Academy. Thank you for joining me on my journey, from a 10-year-old with a lawnmower engine to leading Unity Racing to national championship success. Every step, every setback and every success has sharpened my skills and fueled my passion. The Academy represents the perfect next step for me to grow, learn and contribute to the field, because at the end of the day, it's not just about STEM racing, it's about what comes next.